So I'm going to start with the posted exams. Two of them have solutions, two of them don't have solutions, right? So I'm going to solve the one, I think it's called D, sample exam D. I'm going to solve those questions. Those should be closest to your exam. The older questions are a little different, the older exam questions. So pay attention, and if you have questions, let's start with an easy one. Evaluate the integral x secant square x dx. Integration by parts, right? Why? Yeah, there is an x here, okay? And there is a secant x dx here. So when you see x square, x cube, integration by parts is likely to help you. Or first of all, substitution. Would substitution work here? There is nothing we can substitute for, right? So substitution is not going to work. So your second best bet is integration by parts. And since there is an x here, there is a likelihood that if you fix u to be x, I'm going to write integration by parts. What do you pick as u? Why?
It's easier.
Because when you take the derivative, because we are taking the derivative of u and integral of dv, right? So picking x as u will be helpful because the derivative of u is going to be dx. Very good. And for the dv, we are going to pick whatever remains, which is secant square x dx. So, in order to find du, I'm taking the derivative of the expression, which is just dx, right? What do I do to find v? From here to here, differentiate. From here to here, what do we do? Integrate. What's the integral of secant square? Tangent? No, it is tangent
Plus 1?
x. Am I right?
No.
Because the derivative of tangent is secant square. So, okay. What's the formula for integration by parts?
U times v.
U times v minus integration v du.
U times v minus the integration
V
v d.
good job with it.
So, we already know what u is, it's x. We already know what v is, it's tangent of x. Minus, what is v? Again, tangent of x. What is du? Dx. What's the integral of tangent x? Does anyone remember?
Len secant plus that.
Log of secant x
Did you do
plus
homework for
some.
Huh?
Did you do homework for
Yeah.
You did?
Does this make sense?
Did you get full mark? Well, every time I get 7 times.
Question? 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 Question from the back? Can you guys read this? Is this big enough? Okay. So these solutions are not posted, so pay attention. Okay?
Is this C, doctor? Version
Yes,
C?
it's just an integration constant.
I mean version C.
Which one?
Version C. This is the
D, I think.
D?
It is D, yeah.
D, right?
Yeah, D.
Now, another one. This is the second question from the same exam. This is exam D. The integral of tangent minus 1 ln of x over x dx. What do you think?
Do substitution first. Use sub.
We can use sub here, right? And try it because it's our best bet. If you see something substitutable, try it. Here there is, because ln of x is inside another function, and if I fix u to be ln of x, what's du going to be? 1 over x. 1 over x is a function here. So there's a very good chance that things are going to cancel out. Okay? So you should go with this substitution. So I'm subbing u is equal to ln of x, which means du is going to be 1 over x. Am I right? So, here, this is dx over x, so this thing has become du, and this thing is u. So I'm very lucky in this substitution. Is there a limit for integration? There are no, so we don't have to worry about changing the limits. So this becomes arctangent of u times du. What's the integral of arctangent?
1 over 1 plus x to a square.
It is? What did you say?
1 over 1 plus x squared.
No, that's the derivative of arctangent.
Derivative? Yeah.
Yeah. What's the integral of arctangent? What's that? How?
You take u as tan inverse and then dv as
Very good. So if you do all of those, then you get u arctangent u minus 1 over 2 log u squared plus x. Plus some constant. U was, what was u? Log of x. Arctangent x minus 1 over 2 log of x squared. Any questions? Now the question 3 and 4 are just like secant to the power something, tangent to the power something, and sine to the power something, cosine to the power something. They are quite straightforward. I don't want to solve those questions. So I'm going to skip to that. And we have solved quite a few of them. So I'm going to evaluate the integral x over x squared minus 9 dx. What's our best bet? Let's start with substitution, right? There's a function inside another function, and its derivative is in this function as well. So substitution should work. Let's put u is equal to x squared minus 9, which means du is going to be 2x dx. So therefore, x dx is going to be du over. Therefore, the integral now becomes du over 2. X is gone. U to the power 1 over. Am I right? We can, but that's just going to be longer, right? If this was 1 over x squared minus 9, then trig substitution would be better. Very good point. Now moving on, this is equal to 1 over 2, the integral u to the power minus 1 over 2 du. Do you remember the integral of u to the power minus 1 over 2? 1 over 2 u to the power 1 over 2 over 1 over 2 plus some constant, which will be equal to u to the power 1 over 2 plus some constant, and this is x squared minus 9 to the power 1 of plus of. Does this make sense? Make sense?
Which question is it?
It's, I think, 5.
But it's not exactly the same.
Yeah.
5 is there is
Yes,
plus
or
1.
that plus 1 is going to complicate things. If you put plus 1, then you have to involve the arctan, the hyperbolic arctangent, which we no longer teach. So I changed the question a little.
Oh, okay.
The hyperbolic trigonometric functions, we no longer teach them. So if you see them in the
Yeah,
old
you have
exams,
the one.
you can just treat them as normal arctangent or normal.
I was going to tell you to haram.
What's that?
This is old. This is like 2015. This question.
Which one? This one? This just
Ten
take it as
years
a
ago.
formula.
10 years. Probably 2014 or.
So you're gonna record the whole thing,
Yeah,
so I can leave.
yeah. Take attendance.
The next one is a bit different. Can you guys see here?
Yes.
Yes.
Evaluate the integral 1 over 8x minus x squared minus 7 square root x. Now, do you see any substitution that we can do here? Anything? Which one? Okay, try to factor this out. What do you get?
7 and 1.
7 and 1, okay. But it's inside the square root.
You cancel the square.
Okay, very good. Very good. That's the right answer. But it's too early. Now, let's think of substitution. That's our first suspect, right? Will substitution work? The only thing we can substitute here is 8x minus x squared minus 7. Its derivative is going to be 2x minus 2x plus 8. Do you see minus 2x plus 8 in the numerator? I don't. So it's not going to work.
Okay.
Your next best bet is integration by parts. But there's only one function here. Which part? Where is the second part? There's no second part. So that's not going to work either. What's next? Trigonometric substitutions, right? But to be able to do trigonometric substitutions, you need to have like expressions like something square minus something square, square rooted. Do we have anything like that in this case?
No.
No, not yet. But like nothing is going to work unless you manipulate that equation first. So our aim in this sort of expressions, if the integration by substitution doesn't work, you have to think of completing the squares. Okay? So this is a complete this square question. What do I mean by completing the square? Meaning I want to write this something squared minus some constant squared. Some function squared minus some constant squared. Okay? That is my aim. If I can do that, maybe after that I can use trigonometric substitutions. Okay? First, I'm going to complete the square. So the expression here is minus x squared plus 8x minus 7. If there's a square here, right, whose square is it? There's an x square and 8x. If you see this,
It's 4.
if their signs are opposite, then
Like this.
here the expression is
This and
minus
this. When he completes the square, he
x
does
square
this.
minus 8x, right?
Totally he could do that.
Whose square has this expression?
X minus
4.
X minus 4, right? So x minus 4 squared is going to be x squared minus 8x plus 16. So this guy is missing a 16, right? So if I add a 16 and I subtract a 16, then there will be a subtraction by 16 here, there will be a subtraction by 16 here. So this completes the square, adding a 16 and subtracting a 16.
9.
So in this expression, I have, this is minus x squared minus 8x plus 7. I need a 16 here, right? So I'm going to x squared minus 8x plus 16 minus 16 plus 7. This is just 0. Doesn't matter, right? Adding and subtracting the same number is not going to change anything. The equality survives. But the square is now exposed. Does this make sense? Does this make sense? Does this make sense? Does this make sense? Pay attention, please. I have my eyes on you, you know. So, now I have x minus 4 squared exposed. That's what we mean by completing the square. So here, minus x minus 4 squared minus 16 plus 7. What's minus 16 plus 7?
Minus 9.
Minus 9. But if I distribute this negative over, this will be 9 minus x minus 4 squared. Is this in the desired form? Square minus square.
No. We need to do substitution. I mean.
Now we can do trigonometric substitution. By the way, like this took me like 10 minutes almost to do it, right? Because I'm trying to explain and explain and explain, that's why. If you are doing it, it will take 30 seconds, maybe less. But you gotta do it a few times, then you'll get used to it, okay? So, now I can do the trigonometric substitution by changing this expression to 3 squared minus x minus 4 squared squared. Right? Now, if you see constant squared minus something squared, what's the substitution we are doing?
Sine.
The sign substitution, right? So, this guy, now I'm going to say x minus 4 is equal to, tell me,
3 sine of theta.
3 sine theta. Does this make sense? This is the substitution we are making. Now, what is dx then? If you take the derivative of this, what's the derivative of sine?
Cosine theta d theta.
Cosine theta, d theta. What else do we need? We need this expression, right? In terms of, so we are replacing x minus 4 by 3 sine theta.
Mexe tudo,
squared.
cosine theta.
So if you calculate this, what are you going to get?
Why did it become 3 sine theta?
3 plus 3 times cosine theta.
Does
this make sense? Any questions? Any questions?
In power of x times 4 into sine of theta.
Any questions?
8
You're still looking at your phone.
9 is the square of if you get the square root of 9
No questions? Okay, very good.
is 8 2 minus
So now can I put everything back into their places in the original expression? I
this
can, right?
relative
So now my integral
a
by doing these substitutions
so if you could
becomes
give this
1 over 3 times cosine theta. What's dx? 3 times cosine theta d theta. 3 times cosine theta, 3 times cosine theta. What happens to that?
cancel.
Cancels out. So the integral is just the integral of 1, which is
Integration of 1
theta. Very good. Now, I need to figure out what theta is. Now,
sine inverse
remember, we did this substitution, right? X minus 4 is equal to 3 times sine theta. Am I right? So, this means sine theta is equal to x minus 4 over 3. Am I right? Can I isolate theta from here? How?
sine inverse.
Take the arc sine, right? So, theta is going to be arc sine x minus 4 over. Therefore, if I put this in this expression here, this becomes arc sine x minus 4 over 3 plus some constant. Does this make sense? So in this case, we are lucky we don't have to do the triangles. But if we had to do the triangle,
Luckily, we are lucky.
if we had to do the triangle, then we would have theta here. Sine of theta is x minus 4 over 3. So I'm going to put 3 for the hypotenuse. Which one is going to be x minus 4? The opposite, right? So this is going to be your triangle. And if you want to calculate this part, this is 9, 13 minus 9 minus x squared minus 4, x minus 4 squared root will be this. And thankfully we don't need to do the triangle. Does this make sense? Any questions? Any questions?
Example.
Yes.
In the example, I got like arctan, then whatever. Then evaluate it. The final answer is very good.
Which one?
If I get the final answer of arctan, then too many numbers. Should I evaluate it into the calculator or should I keep?
Just keep it as is. Just plug in the numbers and keep it as is. You don't, when you are giving your final answer, if the final answer is like decimals, don't approximate it. Just keep it as the final expression. Like it could be like arctangent of, I don't know, like 5 or something. Just keep it as arctangent of 5. Okay. Let's quickly do the attendance. What's that? What's up?
He wants extra time.
Oh yeah, of course. I'll give you time. Don't worry. Done? Does anyone else need more time? Yeah. Please. Okay. Come find me after the class. No. So these are the questions we are solving. I'm going to solve this on the board.
Points just right.
Apparently. Good for you.
Bro, don't make it like delusion lie to you. 8 points is like, and the exam is like out of 7. This is like nothing.
Bro, 8 points is a lot, huh?
Yeah,
It's a
but
whole
you-
lot of grade.
this exam is different. But it depends, like the question for us. You just have to see the quiz.
So it is, as he has pointed out, it's 8 points just to write out the form. Like you don't even need to find A and B.
Yeah, this is
So
not
what's the form here in the first one? Is this one the most simple version?
No.
Can you simplify this more? How?
No, you can't.
No, you can't. In order to understand that, you have to do b square minus 4ac. Now, b square minus 4ac. What's this here? B square is 1 minus
3. 4 times
12, which is minus 11, which is less than 0.
3.
But you are taking the square. So, b square is b square minus 4ac is a negative number. Therefore, this is in its simplest form. You can't factorize this any further. Okay? How about this one? Can you factorize this further? You can, right? So, this is actually equal to 3x minus 1 times x squared minus x plus 3 times x minus 2 squared x plus 2 squared. Am I right?
Yes.
So now for this one, what's the numerator?
AX plus B.
Ax plus b over x squared minus x plus 3. Plus, what's the numerator for this one?
C over X minus 2.
C over x minus 2 plus d over x minus 2 square, because there's a square here, I have to repeat it, right? Plus e over x plus 2 squared, not squared yet, plus f x plus 2 squared.
That's it?
That's it. After the attendance, people have disappeared. No, not you. These people.
The bugs are here.
Okay.
I think they want bugs.
Okay, good.
You know, guns, they will always go bugs.
Right. Okay. How about the second one? Can we factorize this?
Yes.
We can, right? Because b square is 4, minus 4ac is 60, so this is 64, which is bigger than 0. So we can factorize. How do we factorize this?
Take an X out.
You just calculate.
Perfect. We start with taking x out. So I'm going to do it here. X cubed plus 2x squared minus 15x is equal to x times x squared plus 2x minus 50. So basically, I'm trying to find two numbers that multiply to 15, whose sum is 2.
Negative 3 and 5.
Negative 3 and 5 will do that, right? If you add negative 3 and 5, you get a 2. And if you multiply them, you get a negative 6. So this will do. This means this is x minus 3, x plus 5. So therefore, if I want to write this,
A over X.
very good, plus
B over X
Está not
minus
to zero.
plus C over X plus 2.
Does this make sense? It seems like an easy question, but here, first, you gotta figure out that this is irreducible, and second, you gotta figure out this is reducible.
In the exam, should we show like B squared minus 4AC is less than 0? So that's why we can.
If you do that, it is good, better explanation, but if you don't look at this and try to factorize it, you're gonna waste a lot of time.
Good, doctor, we just use this just to know if it's less than or equal to 0.
Yeah. If it is less than 0, if b square minus 4 is
We
AC
don't
is
change
less
it,
than
yeah.
0, then you can't reduce it.
Yeah. But
Done.
when we use it on the other one, it was more.
Yeah. In this one, what's b square minus 4 AC? B square is 4, right?
Yeah.
Minus 4 times minus 15. What's minus 4 times minus 15?
It's
Plus 60, right? So if you add up, you get 64,
more
which
than
is
0.
greater than. Therefore, we can reduce it. Make sense?
Yes.
Okay, very good.
Makes sense.
Now the next question is evaluating the integral, where there is partial
This is the
fractions.
easiest type of question you get. You won't get it. In the exam, this is what you see, right? In the exam, it's going to be like, do not write the partial fractions, but determine the numerator. and if you don't solve, if you solve this, minus 8.
So how do
You
we
don't-
evaluate this
Also
one?
minus 8.
Can we reduce this any further? No, right? X squared plus 1 is not reducible. So what do we do?
Keep it as it is. Actually,
There's not much we can do. The only thing we can do here is
division, long division. Can we do long division?
for what? No, this is partial fraction.
Yeah.
No
So-
need to do that.
Yeah. We don't need to do
Because-
anything here.
yeah,
This
yeah.
is partial fractions.
Would you start putting in?
Exactly. So I want to have 5x squared plus 3x plus 6 over. Thank you. To be equal to a over x plus 1 plus bx
Bx over x
plus
plus
c
1
over x squared plus 1. How do you solve for a, b, c? You can cross multiply. You can put a value of x and try, right? There are a few methods. Doesn't matter what you do. You will find a is equal to 4, b is equal to 1, c is equal to 7. This is homework. Try to find these numbers at home, okay? This is a very good practice.
Do it now, doctor. I want to see how you do it.
Yeah, and I want to see how you do it.
No, you won't be able to.
You will try. It's not too hard. Try. If you don't try, you'll never learn. And if you can't, come for another side. Okay? So, therefore, this integral, the original integral, becomes the integral of 4 over x plus 1 plus x plus 7 over x squared plus 1 dx. Am I right? Very good. So, this is the integral of 4 times 1 over x plus 1 dx plus x over x squared plus 1 dx plus 7 1 over x squared plus 1 dx. What's the integral of 1 over x plus 1?
Ln
Very good.
x plus 1.
Ln absolute value, don't forget about the absolute values, plus, what's the integral of this? 1 over 2
2, yeah.
ln of x squared plus 1. If you do u substitution, you'll get this.
Tangent inverse.
Tangent inverse. Your final answer should look like this. Does this make sense?
It's supposed to start now. But there is another.
Yeah, I think it's all 12 numbers. Easy, right? This course is not as hard as you think. It's not, right?
It is hard.
No. See, if you practice enough, these are very straightforward things. You just memorize some formulas and apply a few techniques.
Professor, it's what is gonna come in the exam. All of us know the concepts and everything. The problem with the
No,
questions
you are being
coming-
generous to your colleagues.
Sorry?
You are being very generous.
Oh.
Just make sure that you understand the concepts. As long as you don't understand the concepts, you shouldn't have any issues. Yeah.
For that eighth question, I got C equal to 2 instead of C equal to 7.
Did you?
Yeah.
Let me check.
What, the numbers? The numbers are correct.
You're right, C is equal to 2. It's only going to change. Thank you. Any questions? Apparently I can't even read my own notes. Any questions? Okay, very good. So now let's look at some improper integrals. By the way, I have some good news. The absolute convergence and conditional convergence are not coming in the exam. It will be included in. Apparently, some sections didn't cover it, so good for you.
So 11.5 is
No, 11.5 alternating series are coming,
Tomorrow, are you
but the
revising?
absolute convergence is not coming.
Huh?
So is it coming in the final professor?
It
What
will
for?
come on
This?
final, yeah.
Physics?
When is physics?
29.
Okay, we have time. Or no, we don't. 29th is Sunday.
Things
29
keep
is
changing,
next
but
week.
once it is finalized, I'll
We have
send you
time
an
to-
email
Okay.
for the final
Saturday, let's
topics.
revise for math.
This is,
Let's revise for math Saturday.
it's a bit disorganized. I'm
Sunday
sorry
I have
about that.
midterm and into 11.
So, now let's try to calculate
You want
this
to
revise?
integral, okay?
Huh?
Pochuj.
1 to 3,
Why? I didn't do anything.
Pochuj.
2x over
Salam Han.
x minus 3 dx. Now, this integral has an issue. What is the issue here?
It has discontinuity.
It has a discontinuity. Where is the discontinuity? At 3. So we gotta be careful when x goes to 3, right? Since 3 is the right end point, right? This integral is from 1 to 3. So I can only approach 3 from the left side. So therefore, this integral is an improper integral. So I must go to 3 from the negative side. 1 to a 2x over x minus 3 dx. Now I can take the integral, right? I turned everything into limits. Now it's possible to take the integral. Now this is limit a goes to 3 from the negative side. From to a. How am I going to take the integral of 2x over x minus 3? Any ideas?
Long division.
What are you going to substitute u for? But before you do that, okay, if the order of numerator is not smaller than the order of the denominator, then you should do long division. Here, they are both of order 1. So you have to do the long division. If you do the long division, this is going to be 2 plus 6 over x minus 3 dx. Am I right?
Yes.
So I'm going to do the long division here. I'm dividing 2x by x minus 3. How many x minus 3's are there in 2x? Or in other words, how many x's are there in 2x? 2 of them, right? So this is 2x minus 6. If you subtract 2x
Minus 6.
2x minus 6, from 2x, what do you get? Plus 6. Because minus minus will make it a plus. So this means 2x over x minus 3 is equal to 2 plus 6 over x minus, right? So in this version, this question is going to become a much easier question because this is limit a goes to 3 from the negative side. What's the integral of 2? 2x, very good. What's the integral of this? Am I right? Okay, now let's plug in the numbers. I'm still limit a goes to 3 from the negative side. This is 2a plus 6 times ln of a minus 3 minus 2 minus 6 times ln of minus. Am I right?
Yes.
Very good. Now, if a goes to 3 from the negative side, what happens to this guy? This will go to, help me out? 6. 6, very good. How about this guy? Now a is going to 3 from the negative side, right? So a minus 3 is going to 0. From which side?
Negative.
Negative side. But there is an absolute value.
So it will be positive and then
So it
0.
will be 0 positive. So if the inside of ln going to 0 from the positive side, then the value of that is negative infinity. And these are some constants there. So what is the final result?
Divergence.
Divergence.
Sir, can you explain again, please?
Which part?
The last one.
This one? If inside of the ln goes to 0 from the positive side, then the value of ln goes to negative infinity. Because remember, the graph of ln was something like this, right? When x goes to 0, it goes to negative.
So,
Yes.
can you just take u?
We do the u substitution from here to here. From the here to here, you are taking u is equal to x minus 3.
I mean from the beginning.
No, from the beginning, if you did u, it's going to be,
Can, and then for 5.
you can, but then it will be the same thing. You can, it will work. If you find it easy, do it.
But Professor, isn't it absolute value? How will it be negative? How will the infinity be?
Inside of the, no, this is 0.
Okay.
Absolute value is inside the ln. The ln do not have absolute value. Okay. So it's important you don't leave these questions here. You put divergence. Okay.
So if you try to find the loan of 0 from the left side, is it not?
The ln function is not defined for 0 and below 0. Only defined for positive integers. Does this make sense? Any questions here? No?
هذه
العرب. ها؟
هي my accent عراقي بس لهجة
Next one is again another improper integral, but this is improper because one side goes to infinity.
راني من شاطئ. انت ماشي؟
First, we have to deal with the improper and turn this to a proper integral. Then we can think of integrating it. How do we change this to a proper integral? What are the problems?
Is that 0 or e?
0.
It's infinity.
Yes, it's 0.
Limit of t to
Very good. There's only one problem here. This goes to infinity, and I don't want something that goes to infinity. Does this have a vertical asymptote? It doesn't have a vertical asymptote, right? So there's only one type of discontinuity or one type of improper. This is limit t goes to infinity, 0 to t, x e to the power 5x squared. Am I right? Okay, now this is a proper integral, right?
Yeah.
Now I can deal with this. What am I going to do?
Use
How?
substitution.
Very good.
use by part.
No, you by parts is going to work, but the u substitution is easier. So put u for this, which will be minus 5x squared. Therefore, du is going to be minus 10
X.
x. Very good. So this limit becomes limit t goes to infinity. So now I did change things, right? If x is equal to 0, what happens to u?
0.
U is 0. If x goes to infinity, what happens to u? U goes to negative. So I should change this with negative infinity, right? And this with 0. Is this? Or rather, actually, we shouldn't do this. If x is t, what is u?
Minus t.
No, minus 5 t squared, right?
Oh, yeah.
So instead of t, it won't change anything. Minus 5 t. At the end of the day, this will go to minus infinity, but it's better to write it this way. And here I have minus 1 over 10 e to the power u du. Am I right?
Yes.
Very good. So this is limit t goes to infinity minus 1 over 10. What's the integral of this?
EU.
E to the power u from 0 to minus 5 t squared. So this is limit t goes to infinity minus 1 over 10. If you put u is equal to minus 5t squared, this is going to be e to the power minus 5 t squared. And if you put u is equal to 0, this is going to be this e to the power 0. Am I right?
Yes.
Very good. Now, e to the power 0 is
1.
what happens to this when t goes to infinity?
Minus
E
infinity.
to the power something very, very big but negative goes to 0. So overall I have minus 1 over 10 times minus 1, which is 1 over. Does this make sense?
Yes.
Question? Tell me.
Makes sense.
Make sense? Okay. Any questions?
Do we always have to change the bounds, or is there a way not to change the bounds?
You have to change the bounds. Or you can take the indefinite integral and put everything back into x, and then you won't have to change the bounds.
Yeah, like we used to do before, right?
Yeah,
No, but why do you start doing it now?
I don't know.
Oh,
Just random.
okay.
It both works.
Okay.
When we are transitioning from improper integrals to proper indefinite integrals to definite integrals, it's easier to change them back.
Hmm.
So in calculus 1, it makes more sense to change it backwards.
Okay.
Any questions? Yeah.
Pretty centimeter, right?
Right. I didn't see any surface area questions in the previous exam. But technically they're included, and there should be questions. Yeah, most probably it's going to be set the question up, but if it is actually calculate, then it's going to be a very easy question. Which one? What's the question? Yeah, it converges. Like if you put a value, you don't have to say it converges. So in this case, just you can leave it here, and it's clear that it converges to a value. But when it is divergent, you gotta write it's divergent, because divergence could happen in a few ways. So just saying it goes to infinity is not really a complete answer. What happened? Someone got very excited. I hope it's about calculus. It's about calculus, right?
How dare you?
Say it's about calculus, please. It'll make me happy.
He understands week one. Week one lesson.
So, next question is 10. Test whether convergent or divergent.
First year.
It's a previous exam. Yes.
First year.
It's already posted.
Yes, bring to. Shop. I take 211.
Is this integral convergent or not? What do you think? Convergent, why?
P series.
Almost P series, but you gotta be careful because see, cosine doesn't matter what's inside, is always between 1 and minus 1. Am I right? Okay, but I have 2 times cosine. So if you multiply it by 2, it's going to be between minus 2 and 2. I have another 3 added to it, right? So if I add 3 to everything, this will be 1, 2, 5. So I found a bound for the upstairs, because here the numerator makes the problem. If it was just x squared plus 1, we know that it's convergent, right? But it is not. So therefore I need to figure out what's happening in the numerator. Luckily, we can just give a bound for it and then show that. So altogether, now if you argue with x squared plus 1, it's harder, okay? What I'm going to do here is that this is bigger than 0, right? Should be. X is a real number, therefore this is going to be bigger than 0. How about this one? Is this less than 5 to the power x squared? It is, right? If I am to use these bounds, then I need to use the arctangent, and then let actually limit of arctangent go to infinity and figure that out. It's a bit longer. But if you change it to this, which means now my integral is, my function is between 0 and 5 over x squared. Now the limit of 5 over x squared is this convergent?
But Professor, should we do that step? The step that you just did?
Yes, of course. Therefore, we found that something bigger than our function is convergent. And our function is bounded by 0, so it can't go to negative infinity. Because in this case, this could go to negative infinity, right? If you don't bound from below by 0,
Yeah.
then there's a possibility that it will go to negative infinity. So you gotta say that it's bounded from below and bounded from above. Therefore, the integral is
Professor, because it's from 3 to infinity, you can say 0, right? Because in integration we have 3 to infinity, we can say
no,
0.
doesn't matter.
We can say all
The
the time.
value of this function, what the independent of x, is always greater than 0. Because see, this is between 1
Yeah.
and 5.
That's right. That's right.
This is always positive.
Yes. If we didn't have that free constant, we cannot conclude that it's bounded to 0.
No, no. Any questions? Yeah.
You said to make sure that if it has a lower bound that's positive.
No, doesn't matter. If as long as there's a lower bound that doesn't go to negative infinity, you're fine. A convergent upper bound and a convergent lower bound.
Professor, what did you write there?
Therefore, the integral is convergent. Make sense? Any questions?
Oh, what? What?
Doesn't matter. The lower bound can be anything as long as it's a convergent. Whose in the integral of the lower bound must be convergent. No, not necessarily. No, it's fine to have anything as long as it's convergent. 0 is convergent because we know that the integral of 0 is 0. So that's the, like, if 0 is your lower bound, then use it.
Why did we show that it's bigger than 1 over x squared plus 1? It's like a usual step, no?
Which step? This one?
Yeah. We could have just said 0.
True. Yeah. Any other questions? Yeah.
So when we do the p-test, we don't care about the infinity?
The p-test works for integrals from a to infinity. 1 over x to the power p dx is convergent if p is greater than 1, divergent if p is less than or equal to. So it's always a to infinity, a constant to infinity. Question? Question? No? Determine whether the sequence one minus 3n over 5n plus 2n from 1 to infinity is increasing
Yes.
or
Yes.
find an upper bound and lower.
You're done studying for this?
How do you solve this kind of question?
This one? No.
So first,
Can I study?
we can
You study online?
figure out increasing or decreasing.
You have found someone in terms Sunday. After that, you want to study for?
To figure out increasing, to figure out
Did you study for Indian?
if a sequence is increasing or decreasing, what do we do?
I studied
Set limit.
No, we compare an to an plus 1, right? Compare an to an plus 1. If an is smaller than an plus 1, then it is increasing. If an plus 1 is smaller than an, then it's decreasing. So let's write what an is. What's an? 1 minus 3n over 5n plus 2. What's an plus 1? We replace n by n plus 1. Therefore, this is going to be minus 2 minus 3n. Very good. 5n plus 7. So how do you compare these? Which one is bigger? Which one? See, the numerator of this is bigger than the numerator of this. Because you are comparing 1 to minus 2. The rest is the same. Which one is bigger? 1 is bigger than minus 2 and 2 is less than 7. The denominator is smaller than this denominator. The numerator is bigger than this numerator. So both ways it's bigger than the first one, right? So this is the comparison.
Still 7. When it becomes 7, 2, 5n plus 7.
Yeah.
Okay. It was 2.
And substitute 1 and then substitute 2 because it's equal. Essays.
Does this make sense? Very good. So if an is bigger than an plus 1, this is
You add, so it becomes 7.
decreasing. Very good. If it is decreasing, then finding a bound is easy because the biggest value will be upper bound will
First
be
one.
the first one. Very good.
This one. Negative 2 over 7.
Very good. So, second part. This is part A. This is part B.
Minus 2.
As an is decreasing, A1 is the upper bound. If it's an increasing function, then A1 is the lower bound. If it's an increasing function, then the first element is the lower bound. Very good. So, what's A1? Minus 2 over 7 is the upper bound. Also, as it is decreasing, it will keep decreasing and decreasing, right? So what's the lower bound going to be? The highest value of n, which is when n goes to
3 or 5.
there.
What do you ready?
The lower bound is limit n goes to infinity of an, which is limit n goes to infinity of 1 minus 3n over 5n plus 2, which is minus 3 over.
He said you play jiu-jitsu. I guess you're Brazilian.
Does this make sense?
Brazilian?
Make sense?
Falas português?
Yes.
Mentira, you're lying.
Which one? Yes, yes, you're right. So A1 is the upper bound because the sequence starts from 1. If the sequence is starting from 3, A3 is going to be the upper bound.
It became minus 3 over 5 because n.
Very good question. Thank you.
And then n
Any other questions?
Yeah, limit. Yeah. Only n's remain. So what is the coefficient of n?
All good?
It's minus 3 over 5.
Easy.
Yeah, this
Very
is
good.
the-
Okay,
yeah,
this is it
limit.
for
Yeah,
today.
one
I'll continue
minus
solving
3, right?
these
Yeah, the rotor,
questions
so
in
we
the
have
next
to-
lecture.
and
And if you have
it's
questions,
not
please bring them
water.
with you.
Yeah.